Hello everyone, today we will start chapter number 15 circles from R.D. Sharma. We will start with example number 1. The radius of a circle is 13 cm and the length of one of its chords is 10 cm. Find the distance of the chord from the center. Now first we will construct OL which is perpendicular to AB. Now since perpendicular from the center bisects the chord, therefore AL will be equal to BL, which will be half of AB, that is 5 cm. Now in triangle ALO, AO square is equal to OL square plus AL square because of hypotenuse rule. Now we'll put the values. AO is 13, OL will be as it is since we have to find the value of OL, and AL is 5. So now OL square is equal to 169 minus 25. OL square is equal to 144. OL is equal to root 144. Therefore OL is equal to 12 centimeter. Therefore the distance of the chord from the center is 12 centimeter. Example number 2. In this we have to find the length of the chord which is at a distance of 5 centimeter from the center of a circle of radius 13 centimeter. Now in this we are given that the perpendicular distance from center to the chord is 5 centimeter and we have to find the length of the chord AB. So now let OL be the perpendicular to AB and OL is 5 centimeter. Since perpendicular from the center bisects the chord, therefore AL will be equal to BL. Now in triangle AOL, AO square will be equal to OL square plus AL square because of hypotenuse rule. Now we'll put the values. 13 square. Now OL is given as 5 square and AL will be written as it is. AL square is equal to 169 minus 25. AL is equal to 144. AL is equal to root 144. Therefore AL is equal to 12 centimeter. Now since AL is equal to BL, therefore AB will be equal to 2 times of AL. Hence AB is equal to 2 into 12 centimeter, which is equal to 24 centimeter. Therefore the length of the chord is 24 centimeter. Example number 3. In this, OD is perpendicular to the chord AB of a circle whose center is O. If BC is a diameter, show that CA is equal to twice of OD. So here let OL, OD, it is given that OD is perpendicular to AB and perpendicular from the center bisects the chord. Therefore we can say that BD is equal to DA. Now in triangle BAC, we can see that BD is equal to DA, which we have proved. Similarly, BO is equal to CO, as they both are radius of the circle. Therefore we can say that DO is parallel to AC and DO is equal to half of AC. Why? Because of midpoint theorem. So now we can write it as CA is equal to twice of OD. Hence proved. Example number 7. AB and CD are two parallel chords of a circle whose diameter is AC. Prove that AB is equal to CD. So we will first draw OL, which will be perpendicular to AB, and OM perpendicular to DC. So now in triangle ALO and triangle CMO, angle ALO is equal to angle CMO, as they both are 90 degree by construction. Now angle LAO is equal to angle MCO, as they both are alternate interior angles, since AB is parallel to CD. Now AO is equal to CO, since they both are the radius of the circle. Therefore we can say that triangle ALO is congruent to triangle CMO by AAS rule. Now we can say that OL is equal to OM by CPCT. Now since chords equidistant from the center are equal in length, therefore we can say that AB is equal to CD. Hence proved. Example number 9. Two circles of radii 10 cm and 8 cm intersect, and the length of the common chord is 12 cm. We have to find the distance between this center. In this we have to find the length of OO dash. Now we will join OO dash such that OO dash will be perpendicular to PQ. Now since perpendicular from the center bisects the chord, therefore we can say that PL is equal to LQ. Now PQ is given us as 12 cm, therefore PL is equal to half of PQ, which is equal to 6 cm. Now in right triangle PLO, which is right angled at angle L, so OP square is equal to PL square plus OL square because of hypotenuse rule. Therefore we will put the values now. 10 square is equal to PL, we find as 6 square plus OL square. Now OL square is equal to 100 minus 36. OL square is equal to 64 and OL is equal to 8 cm. Now similarly in right triangle PLO dash, PO dash square is equal to PL square plus O dash L square because of hypotenuse rule. Now we'll put the values. 8 square is equal to PL square 6 square plus O dash L square. Now O dash L square is equal to 64 minus 36. O dash L square is equal to 28. Therefore, O dash L is equal to 5.29 centimeter. So now O dash is equal to OL plus O dash L. We'll put the values 8 plus 5.29 centimeter. Therefore, O dash is equal to 13.29 centimeter. So the distance between the center is 13.29 centimeters. Example number 14. AB is equal to CB and O is the center of the circle. Prove that BO bisects angle ABC. So in this we have to prove that angle ABO is equal to angle CBO. Now we can see that in triangle ABO and triangle CBO, AB is equal to CB as it is given to us. Now BO is equal to BO as it is common in both the triangles, and AO is equal to CO as they are the radius of the circle. Therefore we can say that triangle ABO is congruent to triangle CBO by SSS rule. So now we can say that angle ABO is equal to angle CBO by CPCT. Hence we can say that BO bisects angle ABC. Hence proved. Example number 15. Two circles with centers A and B intersect at C and D. Prove that angle ACB is equal to angle ADB. So in this we have to prove that angle ACB is equal to angle ADB. We will start with in triangle ACB and triangle ADB. AC is equal to AD as they are radius of the bigger circle, AC and AD. Similarly, CB is equal to DB as they are the radius of the smaller circle. Now AB is equal to AB as it is common in both the triangles. Therefore, triangle ACB is congruent to triangle ADB by SSS rule. So now we can say that angle ACB is equal to angle ADB by CPCT. Hence proved. Example number 2. In this, O is the center of the circle and PO bisects angle APD, which means angle FPO is equal to angle OPE. We have to prove that AB is equal to CD. So in this we are given that angle FPO is equal to angle EPO, and we have to prove that AB is equal to CD. Now we will start with in triangle FPO and triangle EPO. Angle FPO is equal to angle EPO as this is given to us, and angle OFP is equal to angle OEP as they both are 90 degrees, since OF and OE are perpendicular to DC and AB, and OP is equal to OP, so it is common. Therefore, triangle FPO is congruent to triangle EPO by RHS rule. So now we can say that OF is equal to OE by CPCT. Now since chord equidistant from the center are equal in length, from the center are equal in length, therefore the chords are also equal, which means AB is equal to CD. Hence proved. Example number 3. Two equal chords AB and CD of a circle with center O, when produced, meet at a point E. Prove that BE is equal to DE and AE is equal to CE. So in this we will first construct OL, which will be perpendicular to AB, and OM perpendicular to CD. Now since it is given that AB is equal to CD and therefore we can say that OL is also equal to OM. Why? Because chords equal in length are equidistant from the center. So now in triangle LOE and triangle MOE, OL is equal to OM, which we have proved above. Angle OLE is equal to angle OME, as they both are 90 degree by construction. OE is equal to OE, as it is common. So therefore triangle LOE is congruent to triangle MOE by RHS rule. So we can say that LE is equal to ME by CPCT. We'll mark this as 1. Now since OL is perpendicular to AB and OM is perpendicular to CD, we can say that AL is equal to AL is equal to BL and LM is equal to MD. Why? Because perpendicular from the center bisects the chord, and it is given that AB is equal to CD. So now AB is equal to CD, therefore half of AB is equal to half of CD. Now half of AB can be written as AL or LB, which are both equal, and which equal to LM is equal to MD. Therefore we can conclude that BL is equal to MD. We'll mark this as 2. Now we will subtract 2 from 1, which means LE minus BL is equal to ME minus MD. Now LE minus BL is equal to BE and ME minus MD is equal to DE. Hence proved. Now we'll mark this one as 3. Now it is given that AB is equal to CD, which will be marked as 4. Now we will add 3 and 4, which means AB plus BE is equal to CD plus DE, and AB plus BE is equal to AE, and CD plus DE is equal to CE. Hence proved. Example number 5. Prove that the line joining the midpoints of the two equal chords of a circle, that is EF, subtends equal angle with the chord. So in this we have to prove that angle BEF is equal to angle DFE. Similarly, angle FEA is equal to angle EFC. So we will construct OE perpendicular to AB and OF perpendicular to CD. So it is given that AB is equal to CD. And therefore we can say that OE will be equal to OF. Why? Because chords equal in length are equidistant from the center. So now in triangle OEF, OE is equal to OF, which we have proved above. Now their opposite angles, that are angle OEF, will be equal to angle OFE because of isosceles triangle property. Now we'll mark this as 1. Now since angle BEO is equal to angle TFO, as they both are 90 degree, we will mark this as 2. Now we will add 1 and 2. Which means angle OEF plus angle BEO is equal to angle OFE plus angle TFO. Now angle OEF plus angle BEO is equal to angle BEF. Similarly, angle OFE plus angle TFO is equal to angle TFE. Now it is given that AB is now similarly angle OEA is equal to angle OFC, as they both are 90 degree, OEA and OFC. By construction we'll mark this as 3. Now we will subtract 1 from 3, which means angle OEA minus angle OEF is equal to angle OFC minus of angle OFE. Now angle OEA minus OEF is equal to angle FEA. Similarly, angle OFC minus of angle OFE is equal to angle EFC. Hence proved that the line joining the midpoints of two equal chords of a circle subtends equal angles with the chord. Example number 7. PQ and RQ are chords of a circle equidistant from the center. Prove that the diameter passing through Q bisects angle PQR and angle PSR. So in this we have to prove that angle PQS is equal to angle RQS and angle PSQ is equal to angle RSQ. Now it is given that chords PQ and RQ are equidistant from the center. So therefore we can say that PQ is equal to RQ. Why? Because chords equidistant from the center are equal in length. Therefore the chords PQ and RQ will also be equal. Now angle QPS is equal to half of angle QOS. Why? Because the angle subtended by an arc at the center is double the angle subtended by it at any point of the circle. Therefore, angle QPS is equal to half of angle QOS, which is 180 degree. Therefore, angle QPS is equal to 90 degree and is equal to angle QRS, since it is also the angle subtended by an arc from this diameter. Now in triangle QPS and triangle QRS, QP is equal to QR, as it is given. We have proved that the chords are also equal. Angle QPS is equal to angle QRS, as they both are 90 degree, which we have also proved. Now QS is equal to QS because there it is common in both the triangles. So therefore triangle QPS is congruent to triangle QRS by RHS rule. So now you can say that angle PQS is equal to angle RQS by CPCT. Similarly, angle PSQ is equal to angle RSQ by CPCT. Therefore, the diameter passing through Q bisects angle PQR and angle PSR. Example number 13. Bisector AD of angle BAC of triangle ABC passes through the center O of the circumcenter of the triangle ABC. We have to prove that AB is equal to AC. So we will first start with in triangle AOB. AO is equal to OB, since they both are radius of the circle. So their opposite angles, that is angle OBA, will be equal to angle PAO because of isosceles triangle property. So similarly, in triangle AOC, AO is equal to OC. Same reason that they are radius of the circle, and now their opposite angle will also be equal, that is angle OCA be equal to angle OAC because of isosceles triangle property. We'll mark this as 1 and 2. And now it is given that AD is the bisector of angle BAC, which means angle BAO is equal to angle OAC. We'll mark this as 3. Now by comparing 1, 2 and 3, we can see that angle OBA is equal to angle BAO and angle BAO is equal to angle OAC and angle OAC is equal to angle OCA. Therefore we can conclude that angle AOB, therefore we can say that angle OBA is equal to angle OCA. Now since in these triangles angle OBA and angle BAO are equal, therefore, and in this triangle OCA and angle CAO are equal, therefore we can say that angle AOB is equal to angle AOC by angle sum property. So now in triangle AOB and triangle AOC, angle AOB is equal to angle AOC, which we have proved above. AO is equal to AO, common. Angle BAO is equal to angle CAO, as it is given to us. Therefore, triangle AOB is congruent to triangle AOC by ASA rule. Therefore, we can say that AB is equal to AC by CPCT. Hence proved. Example number 14. AB and AC are two equal chords of a circle whose center is O. If OD is perpendicular to AB and OE is perpendicular to AC, prove that triangle ADE is an isosceles triangle. So it is given that AB is equal to AC. Therefore, we can say that OD is equal to OC. And the reason is, since equal chords are equidistant from the center. Now, in triangle ADO and triangle AEO, OD is equal to OE, as we have proved as above. Now, angle ODA is equal to angle OEA, as they both are 90 degree. AO is equal to AO because of common. Therefore, you can say that triangle ADO is congruent to triangle AEO by RHS rule. Now we can say that AD is equal to AE by CPCT. Now in triangle ADE, AD is equal to AE. Therefore, we can say that their opposite angles will also be equal, which are angle AED and angle ADE. So therefore, triangle ADE is an isosceles triangle. Hence proved. Exercise 15.3. Question number 2. A circular park of radius 40 meter is situated in a colony. 3 boys, Ankur, Amit and Anand, are sitting at equal distance on its boundary, each having a toy telephone in their hand to talk to each other. Find the length of the string of each phone. So here let the string of each phone be x centimeter and OB be a centimeter. So we will construct AB perpendicular to SD, and since perpendicular from the center bisects the chord, we can say that SB is equal to BD. So SB is equal to half of SG, which means they are equal to x by 2. So now in right triangle ABD, AD square is equal to AB square plus BD square because of hypotenuse rule. Now we'll put the values. Here AD is x square, AB is AO plus OB, which means they are 40 plus A square, and BD is x by 2. So now we can write this as x by 2 whole square is equal to x square minus 40 plus A square. We'll mark this as 1. Now similarly in right triangle OBD, here where OD is the radius of the circle and radius is given as 40 meter. OB square plus BD square is equal to OD square. Now OB is A, PD is x by 2 and OD is equal to 40 square. Therefore x by 2 square is equal to 40 square, that is 1600 minus A square. We'll mark this as 2. Now by comparing 1 and 2, we can see that x by 2 whole square is equal to x square minus 40 plus A square is equal to 1600 minus A square. Now we'll open the bracket, therefore it will become x square minus 1600 minus A square minus 80A is equal to 1600 minus A square. Since minus A square and minus A square are common, they will get cancelled. Now this equation becomes x square minus 80A, my x square minus 80 is equal to 3200, and x square is equal to 3200 plus 80A, which can also be written as 80A plus 40. Now we'll put this value of x square in second equation, which means 80A plus 40 upon 4, since 2 square 4, is equal to 1600 minus A square. So now we'll divide 80 by 4, come 20, so it will become 20A plus 800 is equal to 1600 minus A square. Now we can see that it becomes an equation A square plus 20A minus 800 is equal to 0. Now we'll use middle term splitting, therefore it will become A square minus 20A plus 40A minus 800 is equal to 0. We'll group these, so it will become A minus 20 plus 40, A minus 20 is equal to 0, A plus 40, A minus 20 is equal to 0. So we'll get two values of A, that is minus 40 and A is equal to 20. We will neglect this value, that is minus 40, because length cannot be negative. So now we'll put this value again in this equation. So therefore x square by 4 is equal to 1600 minus 20 square. X square by 4 becomes 1600 minus 400, which is equal to 1200. X square is equal to 1200 into 4. X is equal to root 4 into 3 into 100 into 4. Therefore is equal to 40 root 3 centimeter. Therefore the length of each string, that is AD is equal to SD is equal to AS is equal to 40 root 3 meter.